so people will actually be on stream to know that I am back. Okay. So while everyone gets situated, and maybe I'll have more than 0 streamers in, let me go ahead and go over recent developments, which is basically no developments. I've been gone for about a month with the bronchitis, which of course nobody has time for. However, I have been doing a bit of reading. So there are some things I'm going to have to change with the program, and some other things I'm going to have to work on. And normally I have a habit of just more or less trying to figure out what I want to do in one stream, getting to that stopping point and just cutting it off. So maybe it'll take me 4 hours to do something, or 2 hours, so my streaming time is not exactly consistent. However, considering that I've come to the point where it looks like I can't pick any more small tasks that would only take me a few hours. So the stream is now going to be until I hit a point where I feel like I have to stop doing stuff for a little bit. So maybe I'll be able to go for 3 or 4 or 5 hours depending on how things work out. 8 o'clock my time, I'm probably going to be very tired by the time it hits midnight. So we'll see how things go. This month I'm thinking more or less collision and physics. If you came in from my my Twitter post, you know that already. Oh my, let me silence my phone. Get distracting. My phone is informing me that I am streaming because I'm subscribed to myself or something. I don't know. Anyway, while I shut those things off, try to get any background noise to not come into the stream. Like I was saying, if you came in from Twitter, from Facebook, or whatever, I'm going to be focusing on collision basically for this entire month. And how, if I don't get far enough where the collision actually works, then I'm just going to have to keep going. But the goal is, sometime in May, I will be done with the collision. Oh, I forgot to put my link up in the Discord. Okay. So there is a Sega Extreme forum and a Sega Extreme Discord, and Sega Extreme is the main forum where a lot of the Saturn, pretty much all the Saturn developers that do anything of worth are there, and also I'm there too. Let me do one quick promo post more before I actually get started digging into what I've been doing. I haven't looked at my own code in a month. I've been looking at other people's code, and I've been looking at documentation. I've been learning some things about how some of the Saturn processors work. I've been learning about the DSP. March of the Square... Okay, Ponut, you're going to have to help me with that. I don't know what you're trying to say. Oh, okay. I mean, I guess that kind of helps engagement, as the YouTubers say, or what have you. Actually, that's another thing. I'm up to 35 subscribers. I actually gained subscribers during my month-long medical hiatus, which freaking doesn't make any sense to me. So, thank you everyone that's subscribing to me on YouTube. Just so you know, Twitch is the place where I stream, and Twitter is where I post all my updates. So if you go down to the description type area below the screen right now, either in YouTube or Twitch, you'll see that I have a Twitter. I would subscribe to that if you care about trying to figure out what's going on with the stream. I post links and updates and stream times, so, you know, check that out. Let me do my one last promo code, and then I will start... Promo code, I'm not selling anything. Promo post. Okay, and then I'll get started. Okay, so, what am I doing today? First off, Ponut informs me that my timer is probably broken, and I believe him because he helped me write it. So, let's go into that. I was looking earlier at XL2's demos. He's got a first-person shooter demo and a room testing demo that he wrote for Ponut. Both of those were pointed to me as examples of where to find how to do proper timing, and it turns out proper timing is just Joe Engine's get ticks. which, as I previously discovered, wasn't really working correctly. So first off, let's run my code and just see if it still runs off the main function. Crap, let me get into OBS and switch the scene over to freaking Sigwin. Every time it's Sigwin. I don't know why there isn't like a native Windows compiler that just handles these things properly. Ow. That was my hand to my controller. Okay. We got... How do I place boxes? Oh, wait. Oh, that's right. The target area is a little bit off. I don't think I've fixed that yet. I think some of you might recall that I did start a stream about a month ago, and I cut off early because I was starting to have a coughing fit. And when those started, basically, I don't want to have to cough on stream for solid, 30 minutes or something. Okay, so Dojin, the reason why we have the Hedgehog theme music in the background is because Sega seems to be the only company that won't freaking claim YouTube videos when there's music in the background. Okay. So I got my model up. The orientation isn't right, and that's probably because of some combination of my Blender export settings and some assumptions I'm making. But that's fixable later. For now, I got cubes on screen, and the idea is... Let me see, can I go through this? Yes, I can. I want to be able to not go through this guy. But at least I see the back face culling is working, because I can't see any of the other faces once I'm through the front. That's good. Yeah, Sega's great. I'm going to go ahead and thank Aaron Weber for that. I don't know if that's accurate or correct, but I'm assuming he has some say in not suing the fans, unlike certain other plumbers. I don't know if Bowser's going to be any better than Reggie Fils-Aime in terms of letting fans do stuff with Nintendo's properties. I'd like to have one or two Nintendo tracks, because they have a little bit more chill tracks for backgrounds. Sega's very in-your-face and blast processing and pay attention to this music. Like Genesis tracks aren't very good for background tracks because they're very harsh and energetic. And Nintendo music, you just put in the background and everyone just accepts that it's there. So, problem is, Nintendo would never let that happen because they'll instantly try to monetize and claim your video, so that's not happening anyway. Okay, so the timer. Let's go back into the actual timer and see if we can't quickly fix that. So I got my timer header. What is that? What is that? Yeah, some remix. That's not staying in. Okay, Phantasy Star, you can stay for now. This number actually turns out, if I can find it, I believe I found out what that was. That was a high frequency. Let me see, frequency. There's got to be a memory map on here somewhere. So I wanted to show you guys what that turned out. I'm sure Ponut explained to me once, but I didn't understand at the time. But now I kind of do. If I can find it. User's manual. Okay, well the point is that number right there actually corresponds to like 0x, something like 0x, a lot of Fs, and a 12. And if we go over to Joe Engine source code, where are you? Wow, that is a downer music. What is that? That's gone. Always PSU with the weird freaking music I have to call. Go to Sonic Heroes. There we go. Okay, SMPC. See, that's why I had trouble finding it. Okay, so if we go into Joe Engine and we look at his time code, there's time and then time header. There we go, time.h. Copyright. More comments. There, this guy. We are reading in this guy. So we're kind of in the right direction, or we're in the right area. We're kind of doing something possibly similar to what he's doing. But if you look at his timing code, it's actually kind of bizarre. I'm not sure if I even understand it properly. Here, we get the get time, and then he does it off a frame count to MCR. I have to figure out what MCR was. So he's doing these weird inline conditionals, where he's checking the state of this memory address and just one. To be honest, this seems nonsensical to me. If this reads to me as and true, which seems stupid, but whatever. I'm sure there's a reason for that. But I'm assuming this is somehow returning the number of frames that have gone by since something or another, based off of some cutoff mark. And here he's actually creating a static tick and then incrementing it. And because this is static, I think this just stays so it doesn't get reinitialized next time you call the function. Thing is, I keep forgetting where they put the memory map. I'm sure it's here somewhere. Map? No. It's always in the front or the back of these documents. There, here's something. Thing is, if we translate that, this guy, wherever this is. Thing is, he defines these memory locations up here, register high frequency, but I don't even see where he uses it. There's register TCR. I don't see where register high frequency even comes in. It's weird. I mean, I know it as a memory map, and there we go. This is mapping. It's right there. So let me just ask the Google right quick. What is... Oh, wait, it's already in hex. Why was I doing that? So 25F8 is somewhere between here and here. So I guess the A bus, something on the bus. We're reading the bus, so we're reading information as it's passing between different locations. What is CS0? Okay, now we can get a little bit more specific. We want F8. So this is past that. This, whatever this is. Chip select 0, which includes 3 times the spaces. Connecting devices, and therefore must be set to include all devices. Make sure there's no excessive change. Huh. Time period from which... let's let this scroll a bit so I can get everything on screen, on the stream. Time period from which this access begins. Date of outpost. Effective only for data that is stored in the address. Okay. So we're looking at 25F8, and this is still past what we're trying to look for. So this is 25FE. There's a clock here. Let me see. But how many ticks of the clock will get me a regular actual clock? Unless 25F80004 is actually the clock itself, which would be surprising to me. Actually, let me see if that actually shows up. 25F8. What? That looks wrong. Is that real? It says here we're in VDP2. That doesn't make sense. That can't be right. And the SU register region starts at 25FE. Cache through address. Yeah, it's the cache through map. Okay. So then... Huh. Okay, maybe this rabbit hole isn't actually going to be. Let me see. Am I looking at the wrong number of digits? Crap. 225 000. No. That was way too early. I actually have to be. That's the thing, though. I was looking the wrong number of digits over here. I was looking way earlier in the CS0 region, which didn't really connect to it. The only way to fit this correctly, 25 F8 000 and no last digit. This first digit has to be 2. That memory that we're probing is here somewhere. It's a unique memory address. I don't think we're doubling up on memory addresses, and that's what he's calling here. So I think he's using the VDP2 somehow. Like, so there's some clock that's going to VDP2. So what do you mean by that? What do you mean those addresses are uncached? What's the significance of that? I mean, you have to be able to write a unique address and get a unique result. So this memory region is not doubled anywhere. So when you're writing x25 something over here, wait, is this right? Oh crap! What happened? Cache through. Oh crap! Is it unique or is it not? Am I looking at the wrong thing? 25 F8. F0, F0, F8. Okay, yeah. The only way to write 25 F8 something and get something meaningful back, you're going to end up in this region. That's the only way that makes sense. So somehow, but how would you even address that? If you wanted to pull something, if there's a mirrored address, you want to pull something from one location, not another. How do you write that code? Is it that we're writing off of processor or right? But the code that we write gets run on SH2, which is a separate unit. So does the code that runs on the SH2 has to? Okay, so yeah. So then, this is the SCU map. Let me find the actual developer's guide for the main CPU. There's SMPC's user manual. Sega of Europe tutorial. Okay. That doesn't seem to be in my... I'm going off of this list over here. So I got a basic introduction manual. And then an introduction from Sega of America. I don't think I've found an, what is it, SOE? Or just Europe? Oh, crap. Okay. I'll just grab it from Discord, and then I'll throw the link up here, and I'll throw the link in the description when this thing gets pushed to YouTube. Oh, okay, he's uploading a literal file, so I'll figure out a way to get it to you guys. I'm sure there's an online link to it somewhere, but once it's uploaded, we'll open it up. We'll try to figure out what's going on here. Because I feel like the only way we're actually going to get a proper timer and not rely on Joe Engine, which is not consistent in behavior with the current tools set I'm using, is I'm going to have to somehow ape this code. And I can't ape this code if I don't understand it. Oh, there we go. So we have a white screen. Okay, maybe I should download this and try to open it in Adobe or something. There we are. Oh my goodness. Oh, I've seen this one before. Okay. Yeah, and here's yeah, I have a copy of this document already. I just didn't recognize it by name. Let me see. What was this called? How to use this tutorial. Okay, so let's try to find that map. So maybe we can find it based off of that memory address. 25F8. There we go. There's registers. 25F8. 12. We were looking for 12? Let me see. Oh, that's useless. That's useless. I'll move that back over to my other screen. Okay. So the code references 25F80004, which is whatever SCNT is. It's read-only, which means it's probably important for the system. And there's only one mention of it. SCNT. It's got to stand for something, right? It's a company. Ponut, please enlighten us. Horizontal count or something like that. I know that the vertical and horizontal blanks are strictly timed in the Saturn, and actually the Sega Developer's Manual says something about that, I think. They even have, like, let me see. I remember seeing a section just on time talking about that. Timer registers. Yeah, page 55. I was reading this the other day. I was actually in an AI workshop, and the guy kept selling us Amazon workspace stuff or whatever. So I wasn't interested in buying anything from Amazon, so I was just looking through this document, waiting for him to get to the actual AI part. And, oh crap, where is it? There was a nice picture showing what was going on with the screen blinking. And I probably lost it. Maybe it's in the main manual, I don't know. No, these are just functions. I know it's in here somewhere. Some blanking function shows a, or it shows what's going on with the screen and how things label it. Oh, there we go. This is what I was looking for. So yeah, they have, they show how basically they're rastering in the pixels or what have you, and there is, there's interrupts you can do to manipulate. What? Oh, there's another remix. Take that off. No lyrics on stream. Good enough. Okay. Anyway, so yeah, there's we're writing certain things, and apparently we're kind of overscanning on the display area. But when the raster reaches certain pixels, the different flags get flipped. So, let's see. Indicates the end of display, after which nothing will be displayed on the screen, even when attempting to display the data. Right. Indicates the beginning of display, although the display... Right. So, it looks like he may be timing things based off of this, then. If whatever the horizontal is... HC something, HCNT, whatever that stands for. So horizontal count something maybe. V blank out, interrupt section counted by H blank in, horizontal blank in. Timer 0 interrupt occurs when values compared to the timer 0 register are the same. So yeah, whenever the raster scanning of whatever is being displayed reaches a certain point, then different flags are set to different values, so you can actually count. I'm assuming this is the pixel count. This would be like 19 out of 300 something or another. Okay. So which one of these is the VDP2? Oh, let me just open it up from the website. VDP2 user manual, version 1.1. Oh, this is a big boy. 5 megs. There we go. Let's look at the map. Oh, there's different chapters. TV screen, display method by interlace, TV screen structure, RAM. RAM address map. Okay, let's look at that. Color RAM, registers. Oh, there's one paragraph on registers. Is that all I get? That is all I get. Just this. This is the map. It's these 3 things. Okay. Okay, there we go. Here's the full map. These addresses are shorter, are they not? Yeah, they look shorter. So there's. So when we send, can we send code over to the VDPs and actually address these parts of memory directly with the code? Okay, that'll be useful later. To me, right now, all of my code is serialized. So everything's in the main loop, and there's no real. Where's the main loop? There we go. Everything's in here, and everything gets output one after another. At some point, in order to use the Saturn properly, you have to core multicode. So at some point, I'm going to have to go into VRAM and start manipulating stuff, because that's basically how you write stuff on screen. If I recall correctly, VDP2 is normally used for heads-up displays and putting sprites up on screen separate from the 3D space. So we got 4 megabits of memory in this VRAM, and then 8 megabits over here for a different portion of the VRAM, or changes according to VRAM capacity being used. It's shown in figure 3.1. Oh, so we can change how much VRAM we're using. Huh. Size register. We can flip that. Why would you volunteer to use less VRAM? What do you gain from that? That's weird. Let's see. Partitioning. So, okay, let's try to get back on track. We know that we're looking for HCNT to understand what timing mechanism Joe is using. If I ever get Joe on stream, I'll be able to ask him all of these things. HCNT. Hey! I have a direct reference to HCNT. Let me see. There's some math going on here. Horizontal, vertical, counter value. So H count. Okay, this actually tells me something then. So if I go back to that picture I was showing earlier, there we go. I'm pretty sure horizontal count, the HCNT, is actually which line of these things, I assume starting with 0, that we're on. For some reason, Joe is checking to see if the value here So he's evaluating this memory section here and seeing if it's equal to... I'm assuming that's 1. Converted to decimal. So yeah, it's 1. It's just 1. I would assume he'd want to start it at 0 if he wanted to start at the top. Ending 1. So we're counting. Oh, okay. So we're counting in this case every even line. So every even line we're counting. Because to me it looks like he's just comparing to see if he's on line 1, but I guess we're only comparing bit-wise the very last or first bit, however you count it. So we're seeing if the last bit is 0 or 1. If it's 0, it's even. If it's 1, it's... No, sorry. If it's 0, it's odd because we start counting at 0. And if it's 1, it's even because then 1 would be the second line. So if it is even, if yes, then we evaluate Joe time get system clock value. Oh boy. And see if it's 0. That looks like a safety check. Where is Joe get system clock value? If I open this up, will I actually be able to see anything? File I'm trying to view doesn't exist. Okay. One would think that get system clock value would be somewhere inside of the timer function, but I guess it could be anywhere. Try core. You know what? Joe has documentation. Why am I looking this way? Where are we at? Oh, that's my code. This is his code. There we go. So let's find out where this function is and what it do. Let's get into Joe Engine's documentation. I can access it. His website will go down on occasion. Is it up? Hey, it's up. Neat. Okay. Let's find... It is no matches. Really? Joe time gets this clock value. That's a function. It's a function. The code compiles, so it's not... It's somewhere. It has to exist. It doesn't exist in his documentation, though. Time gets this... Okay, maybe there's some... What file are you in? You are in time.header. Really? It's in the header, but it's not in the main. Oh, staring right at it. Return this memory address. Now, I don't even have to look that up to figure out that that's probably the real-time clock somewhere. But let's check the memory map to be sure. So that's 6,000 and then 324. So let's look for memory map. Where was it? Okay, so it's a shorter address. Let's try 6,000 and then 324. Okay, that's not helpful. I need a big memory map. I need to find out where the 6,000s are. VRAM... Oh, wait, no, that's not it. Yeah, okay. This memory address exists somewhere. Volatile unsigned integer. So we gotta really dig into the entire memory. I gotta conglomerate all of this information into one document just for reference. Because I'm digging through like 3 different documents or something just to find a memory map. and none of them appear to be complete. Code says, well, the code says nothing, but it exists somewhere, and it has to be somewhere in the system. So the register F, let's see, that was high frequency. So I found that earlier. That was somewhere in the memory map. There. We know we're accessing VDB2 somewhere or another. And this, let me see, 1, 2, 3, 4, 5, 6, 7, 8. 8 digits, and then 1, 2, 3, 4, 5, 6, 7 digits. 7 digits makes me think that it's somewhere in here. 1, 2, 3, 4. I can count. 5, 6, 7. Somewhere in VRAM, but the numbers don't make sense because the VRAM numbers don't even go up that high. Here's some registers that are at the 1000 level, or what I'm calling 1000 for now. At least it looks like it. Wait, what's... No, those aren't memory addresses. What is H? I don't know what H is. It's not... That's not hex. I guess that's a... Okay. So it is hex. I'm just trying to read it as hex. That unit doesn't exist in hex. So 1, 2, 3, 4, 5, 6. These are only 6-digit addresses. We're looking for a 7-digit address. And I'm pretty sure it should be somewhere in VDB2, but not in this map. Yeah, I am. I'm... What I'm looking for is this address right here, and it's shorter than the addresses in the main memory map. I figure it was a sub-address of somewhere in VDB2, but I guess it might not be. It could be somewhere, what, in SCU? How many digits are in the SCU? Let's see. 1, 2. Well, these are 8-digit addresses. That's SGL. Let's see. Can you help me at all? No. Minor. Oh, these are just programming techniques. $6,000. It appears to exist somewhere between the... Wait, is this right? If I'm reading this correctly, then it appears to exist somewhere between the SCU register region and the work RAM H region. And I don't believe that I'm reading it right. So the other way to interpret that is that it's earlier on in the memory map, somewhere in here, in the work RAM H region. Okay. Okay, so Ponut, you're gonna have to help me out on these hints you're throwing at me. So I'm literally just trying to find anything that could fit this address. It's a 7-digit address. I can't even find 7-digit addresses inside of this thing. It's going somewhere. It's reading something in from this point. It says get system clock value. If I were just to take that on face value, I'm gonna look for a clock. There's a system clock. Where is it? Come on. It's not here, then it's a VDP. Go. It's around somewhere. I knew it. See user's manual. Let's see what Sega Workshop has to say. Clock. Nope. Wait, is this the same document as this? Yes, it is. Okay, so I just have it labeled as a Sega Workshop 95. So. I gotta figure out one way or another how to interpret this code, or I can't really use it properly. So this is some portion of the memory. Is there it might be somewhere on the bus. Maybe I have to check a memory map for the bus, if there is one. Oh my goodness, this is a disgusting mess. Okay. What even is all this? Got that little hedgehog there mocking me. So all these are 25 FEs. I mean, these just have the wrong number of digits attached to them for me to be looking in the right place. So, let me see. And look at more registers and see the list. All 25 addresses. I'm looking for one digit less, 6,000. Controlling DSP. Timer registers. Nope. It's not the timer registers. Where do we see the I know somewhere in here is something about a real-time clock. So real. There we whoa. Go back. The RTC. Somewhere in the SMPC. Okay. Is there an RTC reference here? No. What about in here? RTC. RTC. We want the real-time clock because I want to know where that memory address is that they're talking about. Clock. Huh. This looks familiar. This is in the neighborhood of where I want to be. Okay, let's look for the clock in the VDB2 manual. It's not in there. And where else could it be? Let's look at the manuals I haven't checked yet. There's a Saturn introduction manual. Let's try that real quick. Clock. Nope. SCSP. That might be it. Real-time clock. Clock. Nope. There's the SCU user's manual. We've already checked that. BDP 1 and 2. Let's see. SCU, DSP assembler. No, I don't need that right now. SGL Developer's Manual, but that's just for code. I'm looking for memory addresses. It's weird to me that I remember reading about the real-time clock. I remember reading real. There was, yeah, it mentions it right here. Time. The keyword I have to search for is clock. Clock figure is the SCU internal clock. Okay. An address is the... So are we talking about the 6000 address? Where is it? Is it here? No, this guy. So this address here, the 6000 address, that is the A bus and the CS0 region. We were looking at that before, I remember. Let's go back to that memory map if I'm in the right manual. SCU. SCU mapping. A bus CS0 region. So let's scroll down to the A bus section, if I remember where it was. A bus. Let's just look for CS0 because we know that's where we're going. SH2. So the SH2 is addressing the same memory location with different addresses. Oh my goodness. What is going on? I'm sure this document will solve everything. Oh, I have to go. You're pulling up the technical manual on the processor itself separate from Sega. Which, okay, sure, let's do that. Let's find 6000. Let's just look for 6000 first and see what comes up. A cache. What's the exact number? 6,324? Those are just page numbers. Okay. Let's try looking for CS0. A strobe signal. That's a timer. That's good. Spaces to provide... What? Oh. CS0 space connection. Ugh. Scrolling is killing me. Okay, so how do we utilize this though? Is there a memory map in this document that will actually translate into something useful for us when we try to use it? So first off, let's find the memory map. Let's look for a map. Come on. From the beginning. Get me the map. First of all, I can already tell these addresses look too big for what we're looking for, unless we're assuming something. So how did you find out then that this thing right here, this address, is actually the A bus? Because I couldn't make that correspondence. Seeing if this is anywhere near helpful to something else. Okay, but can you tell me where you found which part of the map that was on? Because I couldn't find a useful map in this thing. Let me see. Map. Alright, let's look for it. Map. Map. Where is Dora the Explorer? Address map? Let's try that. Why is the address but 135? Yeah, that checks out. Okay. Haha. Yeah, sure. Okay, by my reading, it looks like it would be somewhere in this space over here in CS3. That's 60 too many zeros over. No, that's the right amount of zeros, isn't it? I'm reading from the right. Am I reading in the wrong direction? Because look, I got 7 digits here. It's 6000324, which would fit neatly in here if we allow leading zeros, which is how I'm interpreting it. Otherwise, what, it would go in here, I guess, or something? But it doesn't look right. It looks like it goes in here, and not way down here. Yeah, but you get results, though. Can't argue with results. My goodness. Okay. I am just confused as all heck right now. It says it's getting the system clock value. First off, there is a real-time clock that has documentation somewhere. I have read it. They refer to it as an RTC. It has to be here somewhere. Let me try this one. Clock. There we go. There is a real-time clock somewhere in here, and it is briefly discussed. Here? Hitachi Motorola controls real-time clock and reset either the entire system or individual microprocessors, such as the SH2, the SH1, I don't even know what that is, some sort of sound card, and another sound card. 6,800. Oh, yeah. That's 68,000. My bad. Sorry. SH2 to interrupt. 68,000 is processing the request that it plays a particular sound. Oh yeah, it's a sound card. Yep. Continually is powered by a battery when the system is off. That's why these batteries last all of like a week when you unplug the thing. All input and output using one of two modes. In direct mode, access peripheral directly. Indirect mode, regularly pulls from buffers latest information from devices. Guess this depends on what kind of controller you use. But I specifically remember reading about the real-time clock, and that is what Joe is calling it, so that I'm thinking that has to be it somehow. SU User's Manual should have something in it about the real-time clock. It does not, though. I'm not dealing with a DSP yet. That is an entire headache for a completely different time in my life. What about the SGL Developer's Manual? It probably has a explanation somewhere. Got links to functions, structure. Okay, there we go. Oh, those are actual memory structures. Not what I was looking for. Memory map. That's the memory map? That's it? Oh, there we go. Okay, if we are to believe that I'm here, I'm working somewhere in this area, then I'm somewhere inside of boot ROM BIOS functions. I don't know that I believe that. Yeah, I don't think that's it either. I'm just reading numbers and making correspondences. BDP1 memory, they are all 25 addresses. None of those are right. BDP2, also 25 addresses, just incremented. That memory map was next to useless. What are all these things? If I'm running SGL, I can call on these guys. Are any of these things a clock? Maybe I can just circumvent this whole confusion. What about time? Let's see. We have real-time clock at time down to the second, which is not incredibly useful. But it's only good for operating as like a kind of clock that you think of as a clock. Nope, nothing in here for that. That's disappointing. And where is the description of actual real-time clock? Let's try clock. I feel like I'm just repeating myself at this point. I know it's in here somewhere. I've seen it. It's definitely not in VDB2. Let's try here. No lyrics. Come on, man. Get me off. Good enough. The actual Hitachi documentation, and then Introduction to game development. I think we're... Maybe it was in the Sega Basic library, but that means I would have to import Sega Basic library functions. Clock. I don't want system clock switching. That's a different thing than what I'm talking about. I'm talking about the real-time clock. Clock. Come on, man. CD overview. I don't need the CD. I mean, I've run out of things to check. Okay, yeah, he's pulling to see if he's running at, what, 50 or 60 hertz. Does that help us somehow? I mean, you need to know either way. But I figured that both the processors are still running at the clock speed. They're just hamstringing their frame updates to that standard. It feels like we should be basing our clock off of the processors and not the frame updates. That feels wrong to me. Isn't there a way to just pull the, Are you freaking kidding? Oh my goodness. Okay. So let us assume that he is getting the system clock value. So there's a clock switch. So I was just there. Clock switch. Okay, switch. Okay, there we go. So he's pulling some value. I assume that's determining whether or not we're at 26 or 28 megahertz then. And that will determine whether or not we use what? These two numbers? Let me guess. The inverse of these is going to be 26 or 28 million hertz or something like that. So yeah, if I were to take that number and invert it, if the value is 0, then we get 26 point basically 7. All right, and then let's take this value and invert it. And we get 28 point basically 4. So I'm guessing these parameters have been fit to get like the real actual clock speed of the processor in these two modes. But then what are these two slightly different values? So if we're on an even frame, if the frame counter or the horizontal frame count is equal to 1, we use these values. If we're on an odd frame, we have to use slightly different values. What's this come out to? 26-ish? 26.87. Odd scan. Okay, sorry, not frame, scan line. Odd horizontal. Why do the frame counts seem to change between scan lines? That makes even less sense to me. He's swapping between these two magic numbers, essentially, these two fitting parameters. I'm gonna have to write an article on Shrek on this if we actually figure out what he's doing here, because this is freaking insane. So for the record, I have, let me just spell it out in chat. Shrek, and if I can pull it up, it's my Saturn coding resource that every once in a while I'll try to add to. Let's see, Saturn, homebrew, Oh, there we are. Back. Back. There we go. I have the artist on this one down as who is it? Atsushi Kosugi. I don't know who Sour Pie is, but this is from Sonic Generations, I believe. Anyway, so that's a Saturn coding resource that I try to maintain, but don't do so very well. So anytime I discover something that's, you know, somewhat obvious, or not obvious, but something that looks like it needs to be documented and I can't find easy documentation on, I try to write something there. Ponut's contributed some code to it to show how you can play some music on the Saturn. Still needs a little bit more editorializing by me, but otherwise it's there to look at. Anyways, so I want to go back to the part where we figure out why is Johannes swapping between two different frame timings, it looks like. Okay. And then he's multiplying the results. Okay, so this entire 3-line section just gets you essentially the timing on a horizontal scan line. And then we get a count. Count, where is the count coming from? The count is an input. The input is get Joe time, get frame count. Which is freaking somewhere. Of course. And we gotta go back into documentation. Please don't tell me I closed. There we go. It's under time. It's okay. It's under the time header. Get frame count, and this is return bit shifted by 8 high frequency register. Time peak byte. What is peak byte? Okay, yeah, he's just validating or evaluating the value there. He's bit shifting it by 8 for reasons I can't understand, and he's taken an OR value with peak byte for the low register. Oh, wait. Let me see if I follow you here. Okay. No, okay, no. Okay, yeah, I get that part. So 1 clock is like it's not like milliseconds to seconds, but it's something. So the low clock iterates when the high clock is cycled. Okay. What I'm still stuck on is the fact that we're counting even in odd scan lines and switching up our timings with these magic numbers, which I guess I have to accept on faith in order to keep going with this, because I don't know how he managed to calculate this. I don't see why an even or odd horizontal scan line should change the timing of the scan line. They've got the same number of pixels, right? And I don't know if we're supposed to be counting seconds or milliseconds here, but it looks like if I'm assuming that we're counting, if I assume these values are seconds, let me see. What did Wolfram give me? 28. If I assume these are microseconds? Oh, okay. So these are Value. This looks like it's a value in microseconds. If I'm thinking of this correctly. Really? Really? Is that how that works? Let me go back to that picture. No, not that one. Come on, I got so many documents open. So we had that. Let me see if it was page 55. No, it's not. It's not this guy. Oh, I wish I remember where it was. Coordinates. No, it's not here. TV screen. They had timer instruct. Okay, it was under the timer. Come on, I know you're in here somewhere. Nope, it wasn't that one. Timer. Timer, come on. The SCU manual. Okay, it's in the SCU manual. Where was it? Diagram system block. Timer 0 compare register map. It was probably somewhere in that that area. Page 11. Okay, I'm just gonna search through by eye until I... There we go, this guy. Page 29, I gotta remember that. So every time we do a horizontal scan, we get... So from here to here, it looks like, if I'm counting correctly, it takes like... That can't possibly be right. If this value is in microseconds, then that would be 37 nanoseconds from here to here, then 37 nanoseconds from here to here. There's no way the timing can be that precise and that regular. But that's how I get this this clock rate. Maybe I'm thinking about this wrong. When this guy gives me a value, what units is that in? Get system clock value. It's not documented. But I just don't get why it has to change in between scan lines. You're saying it's blanking at a different pixel, but it says here, I'm pretty sure the blanking happens at the same time every time, or at the same pixel every time. Okay, so we'll take these guys on faith. He's multiplying it by a count, and that count is coming from then the frames. Get FRC, and going back in the time header. Go time, get FRC. So that's register high frequency bit shifted by 8 to get. Now I got to interpret this guy. We got a high frequency register, which right now we're kind of using as a basic clock. If I go into my timer function, we're using the same high frequency register. It's just we wrote it as an integer as opposed to hex. I should be able to change that, but never mind. So what I'm getting is I divide this magic number, which I believe is... Oh crap, that's not what I want. I want calculator. GOG's about to open up and just ruin my screen. See, as far as I could tell, my timer was working already, but I guess I'm not stressing it enough to find out that it doesn't. God, didn't click on you for real. I divide by 60. I get 128. 128 times 60. Fix high. So this is in itself is 30 times. Okay, so the high frequency register is iterating by 256. And then I have this correction factor of 30. So when I'm bit shifting it 8 times, 256, I believe, would be 2 to the 8. Oh, I can't do it that way. Let's see. 2 power, where's power? To the 8. There we go. So if I bit shifted 8 times, I find out if it's at 256 or not. And when it becomes 256, or where are you? Where's that or statement? There we no? Where is it? Oh, freaking God, go away. There we go. So if this guy is 256, the high frequency register, or the low frequency register is 1, I guess? So when this guy becomes 256 or this guy becomes 1, I'm assuming this guy iterates between 1 and 0 in order for this to work in a sensible manner. So this basically has to return a true or false, right? That's all it can return. Because this is basically an 8-bit number that's being bit shifted 8 times, so we're only getting the top digit. And this guy, being compared to it, is probably also like just a single bit. But that's not what's going on here. He's not concatenating. This is an OR, is it not? Or, wait. Am I reading this wrong? Binary OR. Okay. But either way, it's working the same way, right? It's taking whatever digit we get, the top digit here, and doing an OR with this. But wait. If this is bit shifted 8 times and this thing's only allowed to go up to 2 to the 8, that means it can only be 0 or 1 at that 256. And then this guy, you're saying he's a full 16-bit number. Okay, I'm gonna need that. I'm gonna need to type that one out. So we're gonna have a. Let me see. Okay, so we're not reducing it. I was reading it as a right shift, I guess, or something. So we're multiplying it by 2 to the 8. So we're taking 256, or we're taking some number. So if I was to write, I'm going to write here, but I'm not going to save because I don't want to save. We take whatever high frequency. I'm going to call HFRC times 2 to the 8, which is basically 256. And then we take an OR statement, which is basically just adding it to whatever's in the low register. Well, it's probably going to be too fast for me to actually see, but sure, let's do that. Why is GOG still open? I'm getting notifications now. And more importantly, why does Ultimo 4 need updates? That doesn't make any sense. Okay, Okay, let's try this. Given that high and low frequency registers are here. Okay. So this is not actually that. It's going to be... Well, it is actually that, but let's write it in the appropriate fashion. It's going to be 12 and 13. Where's my code? There we go. Make sure I have the right number of Fs. 12. And then frequency low. 13. And I'm going to give it a... we're returning what looks to be a uint16. Because we're concatenating. Let's call it test clock. Void. And we're going to take, let's see, return. Okay, so we have to evaluate the value here. So what do? We do star that? Am I reading that right? My C is now rusty enough where I have to check this. Peak byte does what? Just copied. Why is it a char? Okay, so let's do straight up shameless shameless appropriation. MCU frequency high, and then take this bit and shift 8 places to the left, make it bigger, not smaller. Okay. I also gotta get this thing instantiated in the header as well. And on the display, where am I displaying all this crap? Input and game object, which means my display model. Display, load reference, my draw. There we go. Print statements. That's what I want. Am I printing anything right now? Like, where's all my... What are my print statements doing at the time? Got game object, we got input. Do my inputs give off print statements? Yeah, there we go. Print orientation. So let's put that here. Time. Let's move it out of wherever I put it here. Come on. Okay, no, that was just still a comment. It's harmless. That. Are we importing time? We are importing the timer. That's good. So let's take the result of not this. Okay, let's close out of this so I stop getting confused. I can open it back up later if I need to. Test clock. Result of text clock. Test clock. Yeah. To fixed. There we go. Text clock. And then we're going to want to put on time is 0, 1, 2, 3, 4, spaces 5, started on 6. Sounds right. Row 7. Six, 7, no, not 6, 0. Okay, let's see what this actually looks like. Uh-oh. In function, gamepad input, wait frames, print orientation, void. SL print FX. Did I screw something up somehow? Input. Input.c. How did I screw that up? Okay. Line 121. Oh. That shouldn't be there. Okay, that looks fine now. Hey. Okay, timer 28. MCU frequency undeclared. No, it's not. It's right there. Oh, whoops. That's Oh, I should probably also declare this over in the header. Oh, I should switch over to Mednafen. Okay. Oh, that was helpful. So it's alternating between very low and very high, I believe. Okay, maybe I need to use a different print statement. Maybe print fix is not the way to go here. I know there's a print integer. Let's try that. The output statement should be giving me 16-bit integer, right? Yeah. That's not the problem there. I need to be able to print a 16-bit integer. I thought toFix would be able to translate that, but apparently not. Where is my SGL? There we go. SL print display hex. Okay, print fixed, print hex, print matrix. Print matrix. Oh, okay. Get matrix, initially. Okay, so I only have a limited number of print statements, and most of them are of limited usability here. SL print takes in a string. Can I use it just for digits? Okay. Let's try that again. I feel like that is not what is supposed to be happening. But it's an interesting effect. Yeah, the fact that it's able to write past the limits of the screen that I gave it is odd. Let's go back to making it fix. Thing is, it's an unsigned integer. Why is toFix giving me freaking digits? Okay. Okay, let's go back to what it was. This thing changes far too slowly for me to be able to keep track of it. I need to find a way to hang the program once. If I don't fix the number, how do I print the number? Because the SL print is not going to do it. If I don't fix it, let's just see what it looks like. That's somehow less useful. What I need is a way to hang the program on command. Just make it crash. There's got to be some way to do that. Yes, what I want to do is I want to take just 2 time intervals. I want to display the frame once with the 1 time, and then on the next line display the next frame, print the next time, and then crash it. I just need to get a delta here just to get my mind around what's going on here. This thing is moving too fast for me to actually comprehend what's going on. Basically, yeah. But either way, I need to find a way to get this this should work. This should just... What do you mean accumulate it? Huh. So here's how I understand what's going on. One counter at the very minimum is iterating between 0 to 255. So what I'm writing, let's just duplicate this real quick. What I'm writing is going to be in binary up to 1, 2, 3, 4, 5, 6, 7, 8. And then it could be 1, 2, 3, 4, 5, 6, 7, 1. Binary to decimal. One, 2, 3, 4, 5, 6, 7. Thing is, this thing is getting really massive. And the weird thing is, the high frequency stuff that's changing very rapidly is the stuff he's putting in the higher digits place, which doesn't make sense to me. So, like, what would end up happening is, let me see, where's the 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So I would end up iterating between 511 and 1, 2, 3, 4, 5, 6, 7. I would iterate between 511 and 66,000 faster in basically one iteration somehow before any of the other digits on the right actually change. So it's still confusing to me how this is useful. So let me open these guys back up. Okay, let's figure out what register TCR is, because he's using that too. I'm going to regret this, but let's look at what TCR is. Where is that timer? Yeah, forget it. This is also something. I don't know what it does. Okay. Nothing high frequency here. High frequency. No. Oh, these numbers look familiar. I wonder if I take this guy. No, not that. Oh, don't make me remember. Okay, 26,874. 26.874 megahertz minus that. Oh, no. 26,680, 58.75. Okay, let's just see what this matches up to. So he's got this value that goes to 28.6364 megahertz. My god, so that's pretty much an exact correspondence to this. So his magic numbers come from this document. We found out what those magic numbers are. And they correspond. So these magic numbers that come from over here, let me see. These magic numbers over here. These are the inverses in microseconds of the numbers from this document here. And the top row corresponds to 320 resolution. I'm guessing 320i. And the bottom row corresponds to 352i. Interlacing. Interlacing somehow affects this thing. When you're on even or odd rows, that means the interlace is changed. Wait. That doesn't make sense. No, this register isn't... it doesn't look like this register is the horizontal scan line. This register is telling us what resolution we're at. So this value will tell us whether or not we are on 320i and 352i. And with that, we switch between the two different frequencies as mentioned here. And we take their inverses to get the clock rate. And we have to multiply them through by a count. Where is that? Here. Okay. If we're going to ape the Joe engine timer, which works, what we're going to have to do is just basically blatantly steal these registers here. So we have to evaluate register TCR. I still am not sure what TCR is, but it's something to do with one of the clocks that keep iterating. And then mtix is defined probably in the header file as what? Oh, it's not in the header file. Where is it? Oh, not mtix. mcks, which is 3. Okay, 3. It's 3. And 3. Why? Okay, 3. Magic number, we're stealing it from Joe. We'll credit him later. And then bit shift that left by 1 after we also bit shifted it. No, we took 8 and we bit shifted it by whatever this is. To be honest, at this point, I'm giving up on trying to understand what Joe's doing here. If I ever get the chance to ask him, I will. And then I'll try to write an article on it on Shrek. But in the meantime, I think I've got a handle on enough of a handle on what's going on here where I can just confidently say, yeah, he's accounting for how many times things are cycling in in one of these checks. So I'm guessing he's running this callback every so many times. Thing is, I don't know why it's time MCKS, but it's for some reason it's and 3. So 3 in binary would be a bunch of zeros and then 11. So logical AND with that, with whatever is in this register, means that we're only taking the last 3 digits of whatever is in this register. And then that shifts 8 down by... So 8 itself is going to be what? 1 and then 3 zeros? Or 2 zeros? We got our 1, 2, 4, 8. So yeah, what's going to be 8 is going to be 1 and 3 zeros, and then we're going to append it. We're going to shift it left by anywhere between 1 and... okay. That's going to be 1 plus 2 plus 4. Anywhere between 1 and 7, and then bit shift it once again. Mike, I have no clue how this works. Anyways, it looks like we're going to be... What's the worst case scenario here? We take our 8. That's going to be 1, 2, 4, 8. And then we're going to bit shift it by up to 3 ones, because that's going to be what that 3... Or up to two ones. Because that 3 gets evaluated to 1, 1. So we get... No, we bit shift it up to 3, so that means we can get up to this many zeros, and then we get another 0. Binary to decimal. Yeah, so these numbers are just magically the inverse. Well, I mean, not magically. They're intentionally the inverse of these numbers. He is checking the resolution somehow. So that register must tell you something about the resolution. So whether or not if it evaluates as 1, then we're on 320, and if it evaluates at 0, we're at 352. That's the only thing that makes sense. Yeah. So this part, the first 3 lines make perfect sense to me now, given that technical document. Look, it works for Joe, and Joe has done this stuff longer than I have. If I figure out a better way of doing it, I will eventually change my timer. But in the meantime, this works. So the count itself is coming from... where's it coming from? Get it first. Okay, so... I got to go back and follow what I was doing. The count itself is coming from this thing where we're appending the high registers and low registers together. We were investigating that earlier. And then we are multiplying again by 8 bit shifted left by up to 3, and then again 1. That's the part that I'm still kind of stuck on, because it looks like we're iterating anywhere between let's see, 30 and 240. Which does that mean anything in terms of screen resolution, or what's 240 times 2? Just 480? Can we get? Is that the? No, because the resolution is what it is. Is this on the basis of milliseconds? Because this looks like microseconds. That can't possibly be right. If we take this, maybe I'm reading it wrong. Take this, microseconds, and take the inverse. It's in kilohertz and not megahertz. We'd have to be sampling this guy at exactly 1,000th in order for these to be milliseconds to make sense. If it's microseconds, then we get our clock speed back. So this whole thing, this whole thing increments by milliseconds, and I'd buy that. So whatever number this thing should return should be should be an integer number of milliseconds, which is a perfectly fine clock. What I take issue with is that he's timing. Okay, he's timing these things down to the nanosecond, which I guess if he knows the perfect clock rate, then sure. What the heck is this thing? Because this thing is cycling, like I said, between 30 and 240. And that doesn't seem to change. I mean, maybe this thing changes. Maybe instead of 240, we can get... is it possible to get 224 out of this? If I reduce this by 10, what do we get? 120. No. Get 240 and then somehow take away this guy. But then we wouldn't be able to start with 8 and do bit shifting. We'd have to somehow change it. I can't figure out what TCR is. I'll show you where on the memory map it is. It's over here. So let me go back on the memory map. It's 16, whereas high frequency, low frequency are 12 and 13. At 5F E12 and 5F E13. I believe the memory map is back in 1, 2, 3, 4, 5 E12. Let me see. I remember we found it, but I don't remember where. Where do we find the actual? Oh, was it 1, 2, 3, 4, 5 E12? Let me see. Seriously? It's got to be somewhere in here, right? Okay. I remember we were it was here earlier because we were looking at it. It's not here. Okay, I know that. I don't think we're gonna get any use out of this guy. Is it in VDP 1 or 2? I don't think it is. Oh, come on, man. No lyrics. Okay, I know somewhere in here is a reference to frequency registers. Oh, that's not it. This is just, VDB2. I don't think it was here, was it? VRAM size register. Let me see. I don't think that was it. I remember we found it. We definitely found it. It might have been in this the PowerPoint. Go up and we go time. Remember we searched for it and found it when we were looking for time stuff. This is a huge document though. It's a 280 page PowerPoint. Yeah. But we found it. We definitely found it. It was in a table. Okay, let me just check the registers and see. Zero X FFFFF. Nope. sattech.txt. Where even is that? So, yeah, I'm looking through the manuals that I have. See if one of these things... Okay, it's not in there. I'm gonna have to rewatch this stream and figure out, document which pages I found what on. Yeah, I'm having the same issue here. Somehow, I don't even know what TCR stands for, but if I figure out what TCR stands for, it'll help us figure out why he's pulling it. So let me see. Let's go back in that PowerPoint document and figure out megahertz. There we go. Yeah. Yeah, what is this? A group resolution such as this or this? Can be soaked up to it. So these are the magic numbers that we're looking at. So when we do that bit shifting stuff, we're either going to be at 224 or we split this back to 1 and get 240. I don't know how he's making that determination from here, though. No, not here. Here. Yeah, because he's taken 8, which is already Like, if I were to demonstrate what's going on here, I'm assuming that we're taking 8, which is 1, 2, so that's 3, add 4. Oh, no, sorry. 8 is 1, so 8, 4, 2, 1. Clock speed will tell you that. Okay, oh, no, you got caught up there. Yes, but that's what this line is determining. I agree with you. That makes sense, because then he's counting every time we get to a new pixel on the scan line, we figure out whether or not, you know, because I believe that this is cycling for every scan line. So we're taking the count, which is the count of the scan lines that we've done, and we're multiplying it through by the clock rate, and then the number of units per scan line. So every clock rate, we're going to a different part of the scan line. That part makes sense. What I don't get is he's taking this is binary representation. We have 1, 0, 0, 0. That's our 8. We're bit shifting it. We can bit shift by up to 3. And then we're going to bit shift one more time. So first off, I don't understand why we have to bit shift this one more time after we do all this crap. But, oh, no, wait. We do the bit shifting after that crap. Okay. So this will be and 3. So 3 is going to be 11. And we're going to and that with whatever's here. So this could end up becoming, for and, it could be 0, 0, 0, 1, 1, 0, or 1, 1. And we're going to bit shift that all by 1 to the left. So that's either going to be 0, 0, 0, 0, 1, 0, 1, 0, 0, or 1, 1, 0. From there, that will determine how much we're bit shifting 8 by. So 8 could be bit shifted none. It could be bit shifted, looks like twice. That's adding 2 zeros to the end of it. It could be bit shifted 4 times. 1, 2, 3, 4. Or it could be bit shift. Oh, crap. Or it'll get bit shifted. What is that? 4 plus 2, 6 times. 12. No, this is 11 is 3, and then 3 with a 0 at the end of it becomes 4 plus 2 is 6. So 1, 2, 3, 4, 5, 6. Which this number is too big for me to even make sense out of. That's 9. Let's see. That's 1, 2, 3, 4, 5, 6, 7, 8, and 9. It's a 10-bit number. So then the 4 possibilities for whatever we're evaluating here, which will change with that register, is going to be, I'm sure this register can only take up certain values, but what I'm guessing is happening is he's cycling either between this number or this number, and this number over here is, let me see, 1, 2, 4, 8, 16. This is either going to be 32 or 1, 2, 4, 8, 16, 32, 64, 128. So we're evaluating either, well, let's get the other possibilities too. 1, 2, let's see, 1, 2, 4, 8, 8, 32, 128, or 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. We're multiplying the count times the clock speed by one of these 4 numbers. How does that make sense? Because there's a check, we know that this number can change, but it changed so drastically, it doesn't make sense why the timing would float between, let's say, like, the most reasonable interpretation I can think of is the timing's going to float between 32 and 28 times per scan line. What does that mean? What does it mean for the number to go from 32 to 128? I don't think we're going to be using 8. I don't think we're going to be using 512. I think the register that's here at TCR is either going to be like, it's either going to be 1 or 2. Maybe it'll be 0, but I don't think that would make sense, so it has to be probably either 1 or 2, is what I would assume. Which means we're multiplying our whole count by either 32 or 128. What does that mean? I'm sure if I asked XL2 to get on stream, he could look at this and immediately tell us what's going on. Or even better, if Johannes was somehow online for once, but I don't think he's ever going to be online. Yeah, he's definitely offline. XL2, I keep summoning to chat, so I don't think I want to summon him now. Ponut, I'm open to suggestions. I want to know why we're floating between these numbers as multipliers for the number of counts per scan line. I know we got at least a couple other people in chat. If you guys have like some crazy ideas, even if you're not programmers, I'd love to hear them. We do need to know what TCR is, and we need to know what values it can take up. For all I know, it could be floating between 0 and 1, which means we're floating between 8 and 32. But we have to find out why the registers are where they are. Let me see if I can find a high frequency. Nope, it's not in here. Okay, contents. Let's figure out register map. Well, maybe it's in the register map. Yeah, me too. I thought we saw them earlier in the stream. So, somewhere in this register map is going to be not only the pointer for the high and low frequency portions of that timer block, which is over here. There we go. So we got quintuple F E12, quintuple F E13, quintuple F E16. Low and high frequency, that is kind of self-explanatory. And then the TCR. We need to know what TCR is. Let me see. Maybe if I Google Saturn TCR, that'll tell me something. So, okay, maybe we didn't see it. I'm getting Tiger Claw Radio. That's clearly wrong. Huh. Here's an interesting document. So here's some guy talking shop in a document called Why Certain Platforms Fail. TCR. Could that be referencing something different? Oh, come on. Don't be that guy. Yeah, I don't think that was helpful. Never mind. So we can interpret what Johannes meant by frequency here, TCR register. Okay, let's go back to the memory map in SCU. And figure out what's going on here. What does that mean? Okay, never mind.
Finally, we can relate. Our side by side is fate. I knew all along we'd find some way.
Nope. There we go. That's a bit much. Skip to the next one. Interrupt control. These are not even close to the right registers, but I need the map. Okay, let me try this way. High and low level, high and low level. This is just brute forcing a search here. Looking for some reference to the frequency. The Hitachi document? Seriously? Okay, fine. Where is that, crap. I downloaded it recently, too. It's not this. Let's see. High frequency. Nope, I don't think that's it. Maybe I can figure out what a TCR is from this document. Or TRC? TCR. TRC looks too much like a clock rise time. That can't be it. That can't be it. Hello? Hey, do these guys look familiar? Because they look familiar to me. Okay. We got a frequency counter. I believe this is a high frequency counter. Might be some sort of low frequency counter. And here is the mythical TCR, one behind where we expect to find it. On-chip peripheral addresses. Time control register. What values can you take up? We're reading the first 2 bits here. So we're reading what these 2 guys are. So remember, we are doing and 3. Where is that? Yeah, so this is 3. We're doing and 3. 3 is 1, 1. So we're taking the first 2 members of this 8-bit object. These 2, the first 2 bits of the 8-bit object over here, and we're finding the union between the 2. Holy crap, dude! There it is. Huh. Okay. Wow. So it counts. Huh. So this will exactly compensate for these clock factors here. So this guy is saying, okay, if I'm set to value 0, I'm counting on every 8th. Every 8th clock tick. So yeah, it's only... No, I don't think it can ever be this guy. At least not for the purposes of what we're doing. If that were the case, then Joe Engine would default to taking a 512 count, and I don't think that's accurate. I don't think it's ever going to be that in normal operation. So what we're going to have is that factor exactly compensates for 832 and 128. So that means I definitely have to write an article about this on Shrek Now, because this is so obfuscated. We just spent the last greater than 2 hours figuring out why his clock works. But I think we know now. I'm gonna have to reference this video just to figure out. Okay, if I use the word obvious, I didn't mean it, but now we know what he's doing, and if we know what he's doing, then we can translate it for other people's benefit. So this pretty much has to become an article on Shrek Now, because there's no way anyone else is gonna know what the freaking crap is going on here. Okay. With that said, let me port Joe's time frame counter to mine. Dude, I mean, I'm almost ready to call this a day and say, okay, we didn't do collisions today. I promise collisions. I'm a bad person for not doing collisions. But I want to end this on a high note, and this is a high note for me, finally figuring out how the timer works. Because this timer has been the bane of my programming existence since, like, stream 2 or 3 or something like that. Right? I just needed to figure out how to count properly. And as soon as I brought in as soon as I brought in XL2's Z-Stream tools, which is the only way I can get 3D models in, somehow it broke Joe Get Ticks. And without recreating the timer, I'd have no way of actually timing the game, which is absolutely necessary for something that's live action. Or not live action, but, you know, real time. Which is kind of a useless statement now. Okay, so here's what I'm going to do. I'm going to shamelessly steal his code and credit him for it and apologize after the fact. As long as I keep his copyright claim up here in all of my stuff. I even accidentally copied the format for him and left his email there. I think I've got everything accounted for. So here's the get frame count. This is the guts of how he's timing it. We know how every one of these pieces works. I have to replace this with a 3. Peak byte is just an evaluation. Here's the thing. These are all everything that's being used here is a memory address that's in the Saturn and is being operated by the hardware. So as long as I translate everything correctly, the timer should still just work. So we're gonna evaluate time get FRC, so time get frequency. Frequency or frame count. That's frame count, not frequency. Even though he uses the same phrasing for both. And that's over here, time get frequency, as this thing that we've already ported over as this concatenation of the high frequency and low frequency information. So really all I have to do is take that, port that directly into here, divided by, or to port that directly into here, which gets pointed here. So it becomes, I can just replace this count with this line and comment on why it works. And then we have to set the frequency, or set the frame count to 0. So set frame count. Oh my goodness, we gotta go deeper. Okay. So we're setting something to 0 and poke byte. 0 bit shifted right by 8. That's weird. Well, 0 bit shifted right by 8 is still 0. 0 bit shifted anywhere is 0. Oh, there we go. Here's the coughing. Okay. So, what's a poke byte? We are setting that volatile to 0. Okay, so basically all we're doing is we're iterating the counter and we're resetting the frequency count. So I'm guessing we're just pulling the frequency fast enough for that not to be a problem. So Joe is manually going into the memory of where the hardware is counting time. The hardware is going all Rayman on us and starting to count all the clocks that are coming by, and then we force it to reset to 0 every time we grab some information from it. And we're doing this basically every game loop, every time, forever. So it never gets a chance to count very high, so that makes the math kind of work out. I don't know why this is split between so many functions when all this just serves to give us a time. What I would do is I'll put this all in one function with all the registers correctly defined and commented on. And I'll say, okay, this is what's going on. Here's why we're multiplying by this, and that. Here we have to reset the values to 0. This entire function just gives you time in milliseconds from previous tick to next. And on that note, unsigned integer, Saturn's a 32-bit system, so what's the highest unsigned integer we can make? So that's 2 to the 32 minus 1 milliseconds, 2 days. We cannot leave the Saturn on for more than 49 days. So there aren't even any real checks that we have to keep track of to make sure we don't roll over. So this timer just works for reasonable operation. I'll put in a safety timer just to make sure that it doesn't overflow. I'll just say, okay, once you've reached 2 to the 31 or 2 to the 32 minus 10 or something like that, just stop counting. That actually might be a waste of a cycle. I'll just not do that and just count on people not to leave their Saturns on for 2 months. I feel comfortable with knowing how the timer works and therefore stealing it and crediting Johannes. So let's do that. So time is a fixed. So if we're returning this in milliseconds, so what we should do is divide it out by 1,000 again and make it fixed. In that way, whatever time we get is actually going to be in units of seconds and a fixed value, which works better for me. And maybe some other people, I don't know. Okay. So here's the first thing. I'm going to call this a unsigned integer get time. And okay. To start, Joe Engine sourced adaptation. Joe Engine source timer adaptation. Okay. First thing we do is set old time for iteration. We need to copy over the TCR register. TCR, and for the record, TCR is time control register. Time control register. TCR. You're not wrong. SH2. Oops. SH2. This is SH2 as well. Meaning that this guy, so as not to break existing code. Yeah, let's comment this guy out completely. I'm not using him anymore. Okay. Did we ever figure out what the low and high frequency pointers to SH2 registers found by Johannes, contributed by Ponut. Okay. So this is not a time control register. This is high frequency register, and actually, since we're on the page, should tell us. There we go. Free running counters. Oh, it's not frequency, it's free running counters. Free running counter register. Reading is fundamental. Okay, so access FRCH first and then FRCL. 2 8-bit units. Okay. So 8-bit means it'll go up to 256. Counts up to 255. Then iterates FRC low. Or FCR low. So these are literal clock counts. This is as close to hardware as we can get for a clock. So this is the perfect clock counter if you're running off of the main CPU, which is why Johannes did what he did. So he really knows what he's doing. We know that much. And it iterates it. So, low free running counter increases every time FCR high reaches 256. Time control register. And then that's time tracking in seconds. There we go. So we set old time for iteration. It's the first thing that we do. Oh crap. Okay, we're gonna make this comically huge return statement. No, we can split this up and try to make sense of it. So first thing we're going to do is clock speed from frame rate based on resolution register. And so there's resolution and NSTC versus PAL. So let's call this a uint 16 delta time is equal to this long complicated OR statement. Okay, we finally figured out the timer for real, guys. This is the end. This is the end of dealing with the freaking timer. I really hope I copied that right. Yeah, it looks close enough. Yep, there we go. Okay. Then we have, what is the count? What are we inputting for the count? We're putting get FRC. So count is the input argument. It's an integer. Get FRC. That's defined in the header. Get FRC. Get F. Sorry. Get. There we go. This is a weird remix of My Sweet Passion. I have no idea how I got it, but I have it, so whatever. Let's call int count equals this. We'll change that to get free running counter value. That's why it confused me, because he put it down as FRC when it should be F. Oh, is it FRC? Free running counter. Huh. Okay. No. My fault. I interpreted that as frequency, which I don't think anyone can blame me for. And there's FRC low. Okay, that's the free running counter. You got the count part. And now determine if count is on 1/8, 1/32, or what is it? 1/8, 1/32, or 1/28. Determine if clock is of count. So I'm going to call that a clock clock multiplier. That's what I'm going to call it. So now, oh, this is a void. We don't need to return anything. We just need to set the time. The time is being kept independently. So we can say delta time times count times clock multiplier. And now the timing function makes some freaking sense. Let me just call it the timer function, because it's I don't need to retrieve anything. It's just it's a void. It's a void function. It writes itself. Don't need these guys anymore. I think. Peak byte. Oh, no, I still need these guys, because I need to know what peak byte does. Or poke byte? Peak byte or poke byte? Peak byte? 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 Oh, and the poke byte. I gotta reset the counters. Because he does that here. So we got peak byte and poke byte, and we gotta get both. Okay, so peak is... We'll just append this to wherever it shows up. Yeah, that makes sense. Does it? Yeah, I got that. So what I'm doing is I'm just replacing the peaks with these guys. Like so. This guy not out of place? There we go. I gotta check, make sure I'm plagiarizing correctly. Okay. So then we got the clock multiplier, and then we can set our delta. Set new time, and then what we got to do is we got to reset the counters. Reset free running counters. Seriously, come on. That's done with Poke Bite. Poke Bite is here. And the address is actually... Come on. Where are you? And this date is actually 0. For some reason, when he does it, he makes sure that it's bit shifted right by 8, but it's still 0. Really? Why is that going to upset the compiler? This bit. Here, let me swap out where the... Let me see. Well, first off, let me get rid of this, do that, and just get void. Timer void. There's no longer a test clock. So we're treating it like the first element of an array, which kind of makes sense, I guess. Okay, I mean, I'm fine with that. Did we ever figure out what this thing is? Oh yeah, that's the resolution flag, yeah. Okay, so this, and this are here. We have pole high frequency. So that's there. It's there. I think we can close out of this stuff again. So where do I pull high frequency? It's probably in the main. Let's find pull. Let's try timer. Is anywhere else pull high frequency comes up? Nope. Just the callback. Let's try that. Uh-oh. Oh, that's not surprising at all. It looks like syntax error before semicolon. Is that timer.c? Yeah, 42. What did I do? What has science done? Count undeclared. What? When? Where? What? Okay, syntax error before the semicolon on line 42. There is no semicolon on line 42. Oh wait, no, there it is. So, did I get the wrong number of these guys? Was that it? Yeah, that was it. That was the wrong number of parentheses. Okay. 51. Count undeclared. Is it though? It's declared right there. Let's try it again. Aye. Sigwin. Seriously? Oh, here we are. Nope, nope, nope. Sigwin is... Huh. I haven't seen this error in a while. This is usually a sign that I have too many functions in a script, but that can't be right because I've got like one function in this. Let me try that again. Okay, the compiler is going through with making the file and then test clock. Test clock. It's looking for a test clock. When did that happen? I defined it. Did I define a test clock somewhere? Is there an unsaved reference? Yeah, I don't remember. Like, I remember saying something about test clock, but that didn't stay. It's test box. That's my object. Oh, is it an input? Test. Oh wait, maybe it's here. There it is. I should just get. I believe time is going to be fixed, is it not? Time is a fixed. Time is a fixed, so I can just directly do time. Oh wait. Before I do anything, divide by 1,000. Divide by 1,000. That looks right. Let me just double check to see. Ticks. So ticks are milliseconds. No, wait. He divides by 1,000 again, and that gets us milliseconds. So he's in microseconds. These are microseconds. He's in microseconds. I need to divide by 1,000,000. All right. Yeah. Okay. Try again. I don't know why it let me compile with that reference. That was weird. This song. Recognize it. Huh. Okay, the program is running. Time is 0. No objects are being put on screen, so that's definitely something. Something is broken. What is broken? The fact that I can move around is odd. Number never goes above 1 millisecond. Okay, let's. Okay, first off, I somehow broke the code that lets me place boxes. That's strange. Oh, I'm not accumulating time. That's the first issue. And because I'm not accumulating time, time versus old time is never iterating properly. Yeah, time is still not iterating, so maybe my division is too aggressive. Let's try divide by 1,000 as opposed to 1,000,000. Maybe I just got the numbers right first time. I don't know. Nope. Timer is still not incrementing. Okay, so presumably I'm doing the same thing Johannes is doing. Let's double check. So, in order to get ticks, ticks are in units of milliseconds, which means time frame count to be divided by milliseconds, it has to be in units of microseconds. You get FRC. FRC gives me that crap, and that's why I have this crap over here. This is the count. So my count is already defined as the return statement. I get FRC, which gets put into here. Am I resetting the... bit shift right by 8, just in case. You know what? I'm gonna try not doing this and see if this breaks the compiler. Just to see. It doesn't. It lets me do it. Timer's still not working. Okay. Is it because this is not too fixed? Let's try that. See how fast this will count. Still not counting. Yeah, but all my inputs here are integers, so I have to 2-fixed it. Either in order to save it properly to this variable, I have to 2-fixed it at some point or another. So that needs to be done. What? Why not? That doesn't make any sense. If I wanted to save the number 1 into, like, if I had an output that was an integer, and I wanted to save it into a fixed variable, I'd have to 2-fixed it. Okay, fine. You know what? I'll take this off. Well, no, I'll keep this in here for now, just to at least ensure the data type matches, and then we'll see. Yeah, I get that. But to make the outputs match up, I have to do that. So that's what I'm doing here. So I'm storing time as a fixed, and I'm displaying it as a fixed. So I need to make sure if I'm putting 1 in there, it needs to be that number, that 65,000 whatever. So that's exactly what I'm doing with that. That doesn't explain why my time is not incrementing. Are they not? Also, should they be? Let me see. What is he doing? Yeah, ticks. Static unsigned. Okay, let's make the timer static then. I haven't done that already. Static. But where would I put that? These guys should already be initialized by the time I get here. Over here? I'm not seeing how that'll help, but okay. Initializer element is not constant, line 42. I don't think it likes me doing that to that part. It's complaining on line 42 about the initializer element, which basically means it's complaining about line 40, about that static. I think I have to keep it like this. But why would the static change anything here? Crap. Seriously? Great. Well, let's look at my main function. I'm starting to call the main loop without any callbacks, because that's basically required by Z-Tree. This doesn't seem to do anything, and then I enforce an absolutely true loop as opposed to doing callbacks. So putting the timer in a callback might actually not be doing anything. Let me run the timer as the actual code here. Timer. Okay. Well, I know for a fact that that function has to be doing something. Right? At the very least, the function has to be running every loop, because it's in the main loop now. So the timer itself is not doing anything. So let me just try doing something else. Let me try adding 1 to the timer as opposed to doing this, just to see what happens. See, it's not even iterating by that 1 that I gave it. That makes even less sense. So I can still control. But I'm calling the timer now every frame. It's not even adding 1. It won't do something in this function. Somehow the function is returning. Wait, what? Why is... Oh, I thought you meant my Y coordinate or something. That was throwing me off. Okay. It's 0. I don't know why it's 0, but it's 0. Actually, let me quickly check my inputs. Maybe I'm being redundant here with that one. Yeah, I'm already printing time. I don't need to do it twice. Time is being... oh, this is not my code. This is my code. There we go. Time is fixed and static. Things, it didn't have to be static for me to get it working. Okay, unstatic these two guys. Okay, now time is iterating by 1. Now we know that the timer function is at least running. And it's not crashing. Now let's try to make it an actual time as opposed to counting by 1 every time it's run. You gotta be kidding me. Sigwin, stop complaining. Sigwin, stop complaining. Thank you. Now the timer won't iterate. Great. Do I need to multiply it by some ridiculously big number in order to get something useful out of this? I am staring at the problem. Okay, well, I mean, I'll try that for a second, yeah. But I see what I did that I didn't not do. I have to fix this. Everything here needs to be replaced by its actual explicit function. Get system clock value is this guy. We need to replace that explicitly by this. I need no calls to any Joe Engine stuff. Everything needs to be called from within here. So let's try that first, and then I'll try Joe Get Ticks as a replacement. Global declaration. Oh my goodness. What do you want with me? 41, 22, and 42. Okay, 41. Nothing new here should be... Okay, let's call that its own thing. So that's get system clock value. System clock value. Let's just call that the register for system clock. So I am. Oh, crap. Yeah, it looks like that would fix it. In the meantime... Da-da-da. Sys clock. Now I can just try to do this. Hopefully that will do something. Okay, let's see if that will do it. After this, I'll try Joe Get Ticks and increment that way, if this doesn't work immediately. And it doesn't, but it doesn't crash my program, so... Joe Get Ticks. Including Joe engine, so it should just work if it's working the way it should. That is irritating. So that works somehow, but when I steal it, it doesn't. Something has changed. See, this just makes me feel like it was all useless effort, because now it's working and before it wasn't. But now I've come this far, I kind of want to see this thing properly work. So let me get my print statements and actually do some hands-on debugging here. We start with lines 7 and go onward from there. One of these guys is not doing the right thing. I'm gonna find out who. Zero. So this whole value is evaluating to 0 somewhere. Which one of you is it? Okay, so I should declare it as an unsigned integer. Okay, so we're going to set that off to the side as a register address that I'm just not going to use. And this guy is going to be the actual physical value of system clock. So if that evaluates to 0, thing is, in no situation should that first thing ever go to 0. All of these guys are non-zero. The only options it has is to be non-zero. That's the only thing it can be. And it still evaluates to 0. Then how does it even... Whoa... Wait. But what if I really want to? What if this gets truncated somehow? Okay, so the float... Yeah, okay, you're right. So you know what? All of this needs to be... Okay, this is float. And I've been casting it as an unsigned integer, so it's been going to 0 identically. You can't do that. And when you have an integer and you multiply it by a float and it's cast down to an integer. Do we have to use the float though? How many decimal... Too many decimal places, isn't it? So if we go back into our PowerPoint, describing the frame rate. If I take this and I invert it, that's not useful. There we go. Ah, crap. Okay. We just got to memorize. Let's say 26.8741. 1 divided by 26.8741. If I lose precision, I can define this as a fixed and just use fixed numbers. And fixed numbers, I can get out to 5 decimal places. So if I don't mind losing precision on the timer... Oh, sorry guys, I was doing a little bit of math. If I don't mind losing precision on the timer by 1 part in several, I can keep it as fixed without having to do floating point math. Or I have to stay with floating point math. And when I do that, I have to... Whoops. I have to do the floating point math and can retain it throughout the entire process. And this is happening every frame. Hi! Evav Actress? Is it Evav or Eva? Like Evangelion or Eva VA Actress or... Yeah, I'm lost. I'm sorry. Well, anyway, hi. The stream is running later than I'm used to, but it's only been 3 hours in, so you know what? Screw it. I've promised to work on collision, but you can't work on collision or physics without a timer. And I've been having timer problems ever since I started introducing 3D stuff to the program. So, Ponut and I have been working together on tearing apart the CPU to see where to find the timer stuff and how to define it. Well, I would love to be able to oblige you by making one, but I'm very early on in the process. Right now, we're literally just talking about math. Oh, okay, so you guys are in a different time zone. Let me look up your time zone real quick. Time. It's 3 a.m. Why aren't you in bed? Yeah, I get that. Yeah. Okay, that timing worked out well. Yeah, okay. So right now, I'm debating whether or not I want to keep a floating point for the higher precision, which would be nice. It's what Joe Engine does. Or do I want to keep it as fixed so that I can decide to not give up those few cycles of computation speed. I think it's worth it to keep the higher precision, but I'm not certain. Let's do it. Time add. Time add equals... Okay, C is flexible, so I can do this. Times. You see, it will work without floats. It's going to work with less precision. And that's the thing. Do I want to give up precision for the ability for it to run a few cycles faster? And I'm thinking no. If anything, if I'm going to sacrifice for anything, I'm going to sacrifice for an accurate clock. I want to be able to count right. Because that way, if you change the speed of anything, then gravity no longer feels like gravity. Running doesn't feel like running. Just everything feels a little bit off. Wait, Dogen, how long have you been in chat? Like, I remember you talking up earlier, and then you went away, and then you came back. Eva just got here, and... I'm assuming it's just Eva. I don't know. Anyway, thanks for everyone for coming in chat. This is starting to tell me that I need to start running the stream later, because all of a sudden people are filing in now that I'm finally figuring something out. Ponut's been a real trooper and sticking with me this whole freaking time. It's been, what, 3 hours? We're 3 hours in, and we're still making sure that the timer works. Let's go into Mednafen, run the emulator, see if my version of the timer works. I think it does now, because at this point it's just freaking identical. Yeah, that's what I figured, Eva. Hey, the time works. It feels fast. It feels very fast. It feels too fast by a lot. They're not milliseconds, but they're not seconds. How do I fix this? Ponut, opinions. Actually, is this the same speed as get ticks? Yeah, it's too fast. Let's see. 1 Mississippi, 2 Mississippi, 3. Why am I doing that? I'm on a computer. Okay, 1. Oh shit! I should probably 5. Crap. Now, let me just try to get a good feel for. Okay, 675 basically, and then 10 seconds later. 825. So, let's see. 825, 675. I'm counting 15 every second-ish, roughly. That's not a nice even number. That doesn't make a lot of sense. And the alternative, let's try Joe Get Ticks, see what happens. Yeah, I probably should map a change frame rate button or a cycle frame rate button onto the controller so I can do that. See, the get ticks function also runs kind of fast. Hakun, what we're trying to get at is have the timer run the same time no matter what we're doing with the program. Even if we're overloading the Saturn and there's way too many objects on screen, the timer should still keep time properly because the CPU is not changing clock speed. We should be going off of clock speed. Even if, basically we're trying to divorce the frame rate, which is, you know, how fast the system can run and display stuff with clock speed. I could probably put down objects right now. Yep. The frame limiters are based off of the time making sense, and right now it doesn't. So, Ponut, even with Joe Get Ticks, we're still going fast, so I think we're not concerned too much about the clock speed being wrong. The clock speed being timed to frame rate. I think Joe Gets Ticks is just fast. Either that, or it's not meant to be run on a fixed basis. I think, The end result of this was always divided out by 1,000 to get it into seconds. That too, yeah. It's run on an integer basis. So, first off, get ticks. Did I divide it by 1,000 yet? Go back. There is no division by 1,000 here, but when we go back into his code, was there? There was, right over here, at the end of all this crap. So we get the ticks, we divide by 1,000, that gives us a tick. How is that not already happening? That's set to, for now, milliseconds. Oh, come on. Sigwin, don't be that guy. Look, it goes up by 1 millisecond per, but if we fix that, it still gets displayed as 1. This feels a bit fast. Not quite as fast, but still a bit. Is it speeding up? It's accelerating. Why is it accelerating? Yeah, I can see that. Why is it accelerating? What? The number is getting evaluated the same thing every time, isn't it? Time add gets calculated the same way every frame. Is time add being incremented somehow? I'm still displaying Joe ticks. Look at that. Look over on this side of the screen. Over here. I'm still displaying Joe Get Ticks. I haven't changed anything, actually. I've been displaying Joe Get Ticks, and it feels like it's accelerating, does it not? You are correct. You are correct, and that's dumb. Yeah, I got that now. Okay, whoops. Okay, let me get back into the coding view. This is how we will do this. And now, let us try this. If this works successfully, I believe this will display the time in milliseconds, which will be very fast, but 1 second should go by 1,000. Or maybe 1 second will go by painfully slowly. To me, it feels like the hundredths place is iterating by roughly a second. Yeah, I know 1 millisecond is 1 in integers, but you 2-fix that, and it should be shifted over to the single digits place. Okay. So, in order for this to be sent to actual seconds, I'd have to divide it by 1,000 again, if I understand you correctly. Actually, I need to wrap this whole thing in 2-fix for... Oh, that won't... Yeah, you're right, that won't work. That didn't work. Oh! I'm in a float. Why am I in a float? That I should have fixed that to begin with. No. I can get this to work. Check this out. I'm gonna 2-fix. This whole thing is a floating point. And I'm gonna wrap it in this 2-fixed. And this was defined as a float, now it's defined as a fixed. I was adding a float to a fixed. That was never gonna work. That was an oversight. Okay, it's supposed to be capitalized, right? Did I forget that? Fixed. Time is fixed. Time is fixed. Okay, there we go. Let's try that again. Timer. In fixed point, in seconds, in units of seconds, we have a timer. Did it. It only took 3 hours and 20 minutes. Oh, what am I doing with my life? Yep, we got the box again. The box, got another box. There's another box. Box, boxy boxing. Yeah, I gotta... Actually, I can do that manually. I can put so many objects on the screen. Right now there's, what, 18 objects? 20? So I'm gonna just overload the objects and force my frame rate down from 60 to 30, and that should happen around, what, 40 or 50 boxes or so? When there's a noticeable slowdown... Or... Wait, did I put limiters on the number of boxes? Yeah, I have a limiter. Okay, let's put in a frame rate change command. Is there a quick and easy way to change the frame rate? Like a single SL command or something? What have I got mapped? I got up, down, left, right, rotation, Z, C. B and X are wonderfully open. Let's use those guys. Actually, where's A? A and B. Oh no, A and B are taken. That means X and Y are not. Right? Right. Okay. I'm really into this track. What is this? PSO, I know that. Idola. Okay, this is one of the Dark Falls bosses. Should go back to playing PSO one of these days. Async constant in main. Okay. Frame rate. Sync constant. Where does this become important? Extern. Okay. Oh, okay, neat. Let me just, okay, I'm going to change these two at the same time. So I'm going to add 1 to them, and if they become greater than 3, then I cycle back, right? Yeah, that looks right, okay. Minus equal. And if sync constant, let me just do a comparison on frame rate. It's easier, and they're both being changed. Is equal to 1. Then this, else. This sounds like a PSO episode 4 track. Okay. Let me change frame rate first just to make sure that we're enforcing the right behaviors. Okay. So the first time I press it, it's going to be set to 1, so if I press it, it'll set it back to 3. And then once it's at 3, I can press the button again, it'll filter it down to 2, and then 1. And I want this thing to be not incredibly responsive to button oh crap. Not incredibly responsive to button presses, so I'll put the limit timer on there. Okay. Numbers keep going up and down. Is everyone still with us? Frame rate undeclared. Don't do this to me. Frame rate is undeclared. That means I have to allow it to be what? External? Is that what you want from me? Forward target. What? Oh, wait. That was the wrong thing to do. It wasn't that one. Where is frame rate? Come on. Input 94, 94, 94, 97, 57. You know what? I'm going to do an iterate frame rate function. iterates frame rate. Void frame rate. Enter. Void. I'm just going to do those exact same things. Take off that extern on the frame rate because I'm not going to use it. And then I'm going to come up with the same exact problem, is that I'm going to have to call a function from the main function in input. Can't do the iterate frame rate method. So I'm going to have to, in the main loop, where's the main loop? There. Iterate is equal to int, cast as int, sync constant. There we go. Actually, let me do that down here right after it potentially changes. And of course, I'm gonna have to. No, actually, maybe I'll still use that. Nope. Sync constant undeclared. Of course it is. So. Sync constant is here. Ah, come on. Finally. Okay. I think I have this mapped to X, so X should change the frame rate. Okay, so there's a box. Another box. Why is my delete button not working anymore? I had a delete button for it. Okay, anyway, so let's change frame rate. Wow, that is slow. But the seconds still feel like seconds. Schnozberries still feel like schnozberries. Okay. Next frame rate. Next frame rate. So, my movement speed appears to be affected by frame rate, just not the actual timer. Which means if I start moving my movement speed and other physics over to the timer, it won't be affected by the frame rate. Okay, so 60, 20 frames per second. 30 frames per second. No, wait, this is 20. This is 30. And this is 60. No, this is 60. Crap, okay. 20. I gotta wait a bit for the input lag. It's 30 yet? No, that's 30. And this is 60. Okay. So, what have we learned today? Okay, so if I get right up underneath this, I can delete it again. I just have to fix my target variable, but that's for another day. Yeah, I mean, no freaking kidding. Where did he even find that stuff? Sega never provided those addresses. Sega barely provides anything. Like, I don't even have SBL in here. I should probably shove SBL in there somewhere. But, no, Johannes managed to figure out what the frequency, or not the frequency, the free run encounters were. And then he figured out that we have to count the number of elements in the scan line and somehow compensate for that with that bit shifting magicry. But holy crap. Just to get a working timer. But now that my timer works, I found out that Joe Get Ticks somehow works too before when it didn't. But now that I have my own timer, even though it's his timer, he built it, he did the work to find it, I'll credit him, but I want to use the one I wrote so that it actually works in seconds as opposed to milliseconds. I don't believe you, but I'm willing to give it a shot. Let's see if we can't print the current frame rate. So, in my input, where is it? There we are. Okay. It's a fixed number. So time, position, rotation, target, and I'm sure somewhere else the number of objects are being iterated as well. So on the first line, we only have time. So let's skip over 6 plus 11 spaces, or 12 spaces? Probably 12. 6 plus 12 spaces. Let's start it at 19 then. Frame rate. It'll have to be an int. Well, sync constant is an int, and then I have to 60 divide by sync constant. So that works out. That's not a problem. Well, it's going to be an int either way. It's going to be sync constant is an int, and I have to take 60, which is an integer, divide by that. That'll get me what my frame rate is, or at least the setting. So let me go real quick into the documentation. No, there we go. Just get Joe printf to remind myself how it works, which I think it's just normal printf, but Joe engine. Joe printf, okay, no, you start out with the coordinates and then you do the normal printf function. So the coordinates, let's see, I decided I have to start at like 19, and then we have 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Let's start at 30. This is going to be 30, line 1. It's going to be %d space frames per second. And that %d is going to be 60 divided by sync constant. Oh, I don't know. I'm used to MATLAB. MATLAB uses %d. I think my brain is getting... another Sigwin. Crap. Come on. I'm sick of Sigwin giving me crap. Maybe I'm just remembering it wrong. I don't know why. For some reason, my mind went to %d as an integer. What do you know? Joe printf works now. Is this good? Going crazy or something? What's going on? Okay, 20. 30. 60. There we go. That's nice. Okay, so I mean, I've spent this entire stream figuring out how Johannes Betts made a timer, only to find out that somehow my code magically now accepts his timer and his other commands too. I've unbroken things that were broken before. I can use Joe printf again, where I couldn't. Use get ticks, even though now I won't. Everything worked in a way that is frustrating because now it works even though it doesn't need to. But now I have a solid foundation for doing physics because I've got a time and I've got a delta time by time minus old time. So I can time things like gravity. I can make these boxes fall down next week, next Friday at 8 Eastern. So I can make the boxes fall down and I'll stop them at 0 or just above 0 to account for their width. I've already got basic box collision, but that's not good enough because I want to be able to do rotation. Once I rotate the boxes, the coordinates are going to have to transform as well. So I'm going to have to do some plane-based calculations. So what I'll do is I'll do a little bit of homework throughout the week. I will try to figure out some basic are you in the same neighborhood collision along with actual separation axis theorem that I'm not sure if you guys recall, but the very last complete stream that I did, I mentioned I was going to do a separate axis theorem at some point. And I think I mentioned it on the partial stream where I had to cut out when I was getting sick. But yeah, the plan is a month of collisions, which will extend into May. Now that we've got a solid timer that I know and trust, and I've even got a little nifty frame rate button, even though purpose. I'm going to try and keep everything 60 frames per second if possible. So I'll take off the limiters and see how far I can push the engine. I will start letting things fall. I'll start letting things bump into each other. And hopefully at the end of this, I'll be able to swing a sword and have it register that it bumped into something. And then we can start doing things like statistics and tracking damage. That's months out. Anyway, for now, I think I'm done for the night. It's almost midnight my time, which means it's almost 4 a.m. in Icelandic time if Ava's still awake and with us. I don't think she is. Well, that's the plan. I'll see you guys next weekend. Friday at 8 Eastern, and convert that to whatever time you guys are locally. Good night.